Right, let's solve each of these equations over C. The key thing here is that this is asking you to solve, not to factorise. That's the thing that's different to what we've done previously. So let's look at the first one. We've got A is z squared plus 64 equals 0. This would be awesome if this was a negative, because then it would be a nice difference of squares problem. So let's make it a negative. Manufacture that negative. Okay, and do that by multiplying the 64 by I squared. So what you've got now is you've got z, okay, plus the square root of this thing here, which is plus the square root of 64i squared, and then z minus the square root of 64i squared, and all of that equals 0. And the square root of 64 is 8, square root of I squared is I, so we've got z plus 8i and z minus 8i equals 0. So what that means is our solutions, remember solutions are always the opposite, because you're effectively saying z plus 8i equals 0, and then you're solving for z, so z equals negative 8i. So you're taking that over to that side. So all of your solutions here will be the opposite sign. So z equals negative 8i, it also equals plus 8i, so you can write it like that. You may never have seen it written as a minus on the top, minus plus. It's exactly the same as plus minus, it just means you've got two cases there for what z is. So they're your solutions for z. Okay, the next one here, b, you can see that b is a cubic, which is a bit of a bummer because that means it's a bit long. But what we can do, you can see that these are all real coefficients. So we can effectively guess one of the real factors. And with this one, just looking at this, you'd have 1 plus 3 plus 7. That won't work with a positive. Let's try a negative. So let's try z. Try z equals negative 1. So we've got negative 1 cubed plus 3, negative 1 squared plus 7, negative 1. So all I'm doing is I'm just trialling negative 1 plus 3 minus 7 plus 5. And let's see what that equals. I shouldn't say 0 there. It should be, what does that equal? Negative 1 minus 7, that's minus 8. Oh, and sweet. And 3 plus 5 is 8. So that's 0. So therefore, z equals minus 1 is a solution. And what that means is, because we know that z minus 1 is a solution, that means that z plus 1 is a factor. Okay, and what you can do with that is then do your division. Now I won't do the whole division here because I've done the division in a few of the other videos, so you could actually have a go at doing that division yourself, but it's the division into that big polynomial. And I'll just tell you what the answer to that is, which is z squared plus 2z plus 5. Excuse me. Excuse me, sneezy. Whoa, 3 sneezes. So once we've got the division done, what we can see here is we've got z squared plus 2z plus 2z plus 5. We need to factorise that. So to factorise z squared plus 2z plus 5, or you can use your quadratic formula. So whichever way you want to do that, I'm actually going to use quadratic formula because we've done a lot of factorising by completing the square. So let's do quadratic formula. So we've got z equals negative b plus minus the square root of b squared minus 4ac over 2a. b is 2, so negative 2, plus or minus the square root of b squared, which is 4, minus 4 times 1 times 5. And we did this one before. We actually did this in worked example 19. We found the answer to this, so we know already that this is going to be negative 1 plus or minus. We found that this was negative 16. We made that into plus 16i. So remember that we did one very similar to this in worked example or 19, I should say, not worked example 16, worked example 19. So we found both of those solutions that way. So what that means is finally that our solutions are z equals negative 1 and also z equals negative 1 plus or minus 2i. So you've actually got 3 solutions there. And the reason that you've got 3 solutions is that you've taken the z power here, which is a 3, that, whatever that power is, that's how many factors you should have, and as a result of that, that's how many solutions you should have. So I've skipped a little bit of working in this one. That's a great one just to have a go at yourself. All of the workings are in the textbook, in the worked example, but have a go at the division yourself to see whether you can get this as your answer, and also see if you can get from this point here to this point by yourself as well for your solutions for Z. If we look at C, let's put this on the next page. We've got C and D to look at. So C, you can see that we've got, again, another cubic. Okay, now this particular cubic was the one that we looked at way back. This was the one in example 16. I knew one of them was in example 16. It was this one. So Z cubed minus IZ, squared minus 4Z plus 4I. This was the one, remember, where we identified that Z minus I was a common thing, a common factor for both of those parts. And then we split that up. So we said Z minus I actually goes into both of these. And if we factored out Z minus I, we'd multiply by Z squared to get Z cubed minus IZ squared. And then we'd have here, we'd have Z plus I, and we'd multiply by negative 4, because that would give us negative 4Z, and it would give us, should be a minus there, and that would give us the plus 4 here. So we factored out the Z minus I, Z squared was left here, and minus 4 was left here. They were the factors we looked at, and we also identified that this particular factor here was a difference of squares. So we could split that up into two pieces. So we'd have Z minus I, Z plus 2, and Z minus 2 equals 0. So what that means is then, remember this is asking for solutions. Our solutions are always the opposite sign. So x equals I, and x equals plus or minus 2 from here. This would be minus 2, and this would be plus 2. So you have three solutions. Z equals I, be careful with that, I've put x. Shall we put Z? So Z equals I and Z equals plus or minus 2. Okay, there are two solutions for this particular polynomial. The last one here that we've got is a big polynomial. It looks quite difficult to solve. But what we're going to do is use the quadratic formula for this one. Because we're entirely able to do that, it's a quadratic. Even though there's a lot of i's and stuff in there, we still think about this as having only a coefficient of z, a coefficient of z squared, and then this is like the c. This is the last piece of that puzzle. So even though it has an I, we still consider that like a constant. So I'm going to write down the various parts here. A equals 2, b equals negative 2, and 3 minus I in a bracket, and c equals 4 minus 3i. So they're the parts that I have, that I know. I'm going to use the quadratic formula. And, you know, it's good practice to just write down the formula that you're using, just so people can see what you're doing. B squared minus 4ac on 2a. Okay, and then we're just substituting everything that you have there, and I'll do this, you know, in a lighter blue. It's a bit more interesting. Z equals negative b. Now negative b is 2, positive 2, and 3 minus I. Plus or minus, and we've got b squared, so all of this squared, so minus 2, 3 minus I, all of that squared, minus 4 times a, which is 2, times c, which is 4 minus 3i. So all of that is under the square root. And we've got that over the top of 2a, and 2, that's 2 times 2. So what I'm going to do, I'm just going to put this onto the next page because it's a bit cluttered on this page. Okay, so we can work with it, it's a bit nicer on this page. So we have I'm going to expand this out. So I've got, actually, you know what, let's leave it together because we're going to divide by 2 anyway. I'm going to, inside the square root here, I've got this squared expression. What I'm going to do is I'm actually going to square this first part here. -2 squared is 4. And then I'm going to leave the squared outside the bracket, like that. Because when you have a squared outside two things, if you have a power, for example, outside of a times b, that's the same as a squared times b squared. The squaring actually occurs on both of those things. Okay, so that's what I've done there. Minus 4 times a was 2, which is 8, and then that's c. Okay, and all of that is over 2 times 2, which is 4. Okay, so with this, it's going to get a little bit ugly, but that's cool. I'm going to expand this out now. So I've got 9, 3 minus I squared. If you want to, you can always do this, you know, off to the side of your page. I'm just going to do it over here so you can see 9 minus 3i plus I squared, which is 9 minus 6i minus 1, so 8 minus 6i. So you can just do that off to the side of the page if you want to, and then you can put the result in when you've actually done the workings. So this squared bracket is actually 8 minus 6i, and I've got 4 minus 3i here. I'm going to expand, all of that's over 4. So quite a lot of algebra in this. 8 fours, 32, 6 fours are 24, 8 fours are 32, oops, and 8 threes are 24. Oh, which is pretty funky because that means it all cancels out. It's beautiful. So beautiful. So we've got 2 and 3 minus I left, plus or minus. All of this cancels. 32, this is a plus, oh, excuse me, 24 in there. So we've got 32 here and here, plus and a minus, and plus 24i and minus 24i, which cancel. So we've got a 0. So I'm going to do a little bit more cancelling now. That's going to leave me with a 2 there. So my answer is going to be 3 over 2 minus I over 2. That's what I get to finish off. So therefore, my solution in this case, all right, my solution is going to be z equals, okay, and I should make sure, make sure that I'm writing that down in that form, I over 2. So 3 over 2 minus I over 2. So that's the solution that we get for z. And the interesting thing here is that we didn't get 2 solutions like you would have expected to get. Using the quadratic formula, you'd expect to get 2. But this is one of those situations. Remember, with the quadratic formula, you can get 2 solutions, 1 solution, or no solutions. Because we're dealing now with complex numbers, we'll always get at least 1 solution because we're always going to be able to solve this square root part whether or not it's negative. Okay, so in this case, this just happens to be one of those times where we get 1 solution. So z equals 3 over 2 minus I over 2. Just to finish off, remember that you could use your CAS to solve this as well. So for that last example that we looked at, this big one here, D, what I've done is I've put that into the CAS here. Okay, so I've just put the expression in so I can do that easily. Go into menu. We're trying to find solutions for the equation, so go into algebra, down to complex, and down to solve. Okay, now this expression, because of the way it's given to you here, it's got an equals 0. Okay, so we're trying to solve that expression equals 0. So make sure we put the equals 0. I'm just going to copy this, put equals 0, and then make sure you put comma z so you know what you're solving with respect to. Push enter, and you can see we get our single answer, 3 over 2 minus a half, which is what we got when we did this by hand. So remember that you can use your CAS as well, always a great thing to check with, or if you have the opportunity to use, to avoid having to do all that work by hand.